Hello to everyone and welcome on the YouTube channel School for All. I'm called Paula Eve, the computer science and ICT teacher and the CEO of School for All. So today we are answering one more question on the computer network, and this time we are answering a question on June 25. Good. So June 25 question 5 is a question on the computer network. Now this chapter called computer network is very easy. I don't know why some students have problems here, because I've received so many messages asking, sir, I have problem on the computer network. That's the reason why I'm doing this video. Now, so as usual though, I'm going to summarize what you need to know concerning computer network, not all computer network in general, because I'm going to prepare another video where I'm explaining computer network from zero. Now, but here I'm going to explain all what you need to know to answer this June 2025. When I say all what you need to know, it simply means that the type of question they'll be asking you in the exam is mostly centered around what I'm going to do now. So focus, take your notebook, prepare yourself, and watch till the end. Okay. So as usual, it's like the tutorial first before you start watching the video. At the end of the video, if everything is okay, then now you can leave a comment. Good, a positive comment, of course. Now, so computer network. Other computer networks, in this video, I'm not going to talk about definition of computer network and so on and so forth. My main concern is to answer this question on June 25. And for us to answer this question, we need to discuss about what we call IP addresses. IP addresses. This is a concept in computer network. Generally, when we talk about computer network, it simply means interconnection of two or more computers with the main aim of sharing resources and exchanging information. Now, you need to note something, that in a network, each device is identified by a number. It's like in our country, Cameroon. Normally, each person having a phone must have a SIM card, and each SIM card is having a unique number. So it's the same thing. When we are in a network, each device must be identified by a number. So that number is what we call an IP address. Take note of that. So what's an IP address? In the exam, if they ask you to define, it is very clear. You say that an IP address is a unique number, assigned to each device in a network. Very important. The definition is very easy. An IP address is a unique number. Another person can say an IP address is a unique number used to uniquely identify each device in a network. I think it's also clear. Now, when we talk about IP address, there's something you need to know. We have two types of IP address here. This what we call IPv4, and this what we call IPv6. So I'm saying this one for paper 1 especially. Now, so IPv4 here, this V here simply means version. So when you see IPv4, it simply means IP address version 4. When you see IPv6, it means what? IP address version 6. Now, the next thing, as I'm always telling my students, here at School for All, we are GC oriented. So when I'm giving you something, just know that it's exactly what will help you for your exam. Now, and we are working based on the GCA syllabus. Take note of that. Now, so generally in advanced level, we don't really focus on IPv6, because what we are studying here is IPv4. Why am I saying that? Because IPv4 and IPv6, they are not having the same format. Both are IP address used to uniquely identify each device in a network. That one we are clear with that. Just that the structure of this one is different from this structure. And you people have so many things to study here. Meaning what? It's not possible to study IP address without studying IPv6 address without studying IPv4. It's not possible. Now, since advanced level, people are just getting the base. That's why people are working only on IPv4. Even when you reach university, you will still work on IPv4. It's at a certain level now that you enter into IPv6. In IPv6, an IP address here is represented with hexadecimal number and so on and so forth. So let us concentrate on IPv4. Now, the first thing that you need to understand is the structure of an IPv4 address. The first thing, so let me just say structure. Because if you don't understand this structure, I'm not seeing how you'll be answering questions. So the first thing, you need to understand that the size is 32 bits. The size of an IPv4 address is 32 bits. Now, the next thing, it is divided into 4 equal groups separated by dot. This information is very important. It simply means what? Normal mathematics. If you are telling you that an IP address is made up of 4 groups separated by dot, it simply means what? If the total size is 8 bit, try to make if the total size is 32 bit, try to take 32 divided by 4. You have what? 8. It simply means that 8 group have how many bits? 8 bits. So this is the structure here. You have one group here of 8 bits. separated by dot mean that the difference between this one mean that for you to know how can I say, for you to know the end of this first group, you need to see a dot. By the moment you see a dot, it simply means that this is a new group, 8 bit also. Dot, another group, 8 bits. Dot, another group, 8 bits. In total, 8 plus 8, 16, plus 8, 24, plus 8, 30, 32. So this is the structure of an IP address. Now, when we're talking about bits here, we mean by what? Binary numbers. Good. We know that binary number means zeros and 1. Very good. Now, just that generally, we are not going to represent an IP address using just binary numbers like that, no, because it's too long. You see, writing 8 bits here, 888 is too long. So we are going to summarize it, and the summary that they are doing here is they are converting this 8 bit into decimal number. That is why generally you'll be seeing an IP address represented like, let me just take an example. You'll see something like 192.168. I don't know, 112 dot maybe 8. You see, when you see something like this, simply means what? That these numbers that you are seeing here, they are decimal number, meaning numbers in base 10. That's the meaning of decimal number. The numbers in base 10. And if they ask you to give the binary format, the answer is clear. Binary format of this one simply means you take 192, you convert into 8 bit. Now, I'm assuming that you know how to convert a number from base 10 to base. So this one is normal assumption. I think to convert, what are we doing? We don't do long division, right? If I want to convert this 192 to base, so I just say 192 divided by what? 2. And you take this divided by this, you write remainder this, and the final answer is what? Bottom to top. So conversion from decimal to binary, this one, normally everybody knows how to do it. Any problem, just leave a comment. Just leave a comment. There's no problem. I can still help you to do so. So in summary, what you're supposed to know here is that the size of an IP address is 32 bits. This 32 bit is divided into 4 groups, and each group is separated by a dot, by a point. Take note of things like that. This is an example here. Now, if each group is divided, if this 32 bit is divided into 4 equal groups, it simply means that each group here have how many bits? 8 bits. Now, just that representing an IP address using binary numbers only, it's going to make your IP address to be too long, you see. So to summarize it so that we can read it easily, is by representing each group using what? The decimal system. Meaning that each binary group is converted into base 10. That's why generally you will see IP address having this format. Very, very important, please. Take note of that. Now, the next thing to note here is very important. That the maximum decimal number that we can have here is 255. Why 255 is very clear. Simply because this number here is the highest number that you can represent using 8 bits. It's not possible to come and take 256. You want to represent using 8 bits. It's not possible. When I'm saying it's not possible, it simply means I try to test. Convert 256 to binary. You draw your long division, then you take your answer bottom to top. You count the number of bits. You realize that you have 9 bits. So the last number that you can represent using 8 bits, meaning in this interval, is 255. And the smallest number is what? The smallest number is what? Is 0. Are we there? Good. So the number that you can have here is in the range of 0 to 255. Good. And another way to know this very easily is by doing this. Since a single block is represented using 8 bits, if you take 2 to the power 8, you'll be having something like 256. But since the first address is 0 to 255, if you count in total, it's going to make what? 256. I think you understand what I'm saying here. Meaning what? Imagine that you want to count 10 numbers, and that the first number is 0. Automatically, the last number must be what? Must be 9. So this is another way of interpreting it in fact. Good. So you never, so don't go in the exam hall and you are writing an IP address and you have a number here more than 255. Automatically you are home. So after having this information, very nice. So you just copy. Let me go to the next thing. The next thing here is to understand the format of an IP address. Once you have understood the format of an IP address, you are done. You are done with this thing. Now, concerning the format, you need to know that an IP address is made up of 2 parts. You see, 2 parts like this. The first part here is what we call the network part. Let me change my marker. And the second part here is what we call the host part. Take note of things like that. Meaning what? Let me explain this very easily. The network part here is used to identify a network, and the host part here is used to identify a device. For example, let me just take my phone number. This is my phone number here: 659 25 28 22. Now, if you look this number very well, I'm going to ask for those in Cameroon because I've realized that some people in other countries like Nigeria are following us. They are looking at my videos. So those in Cameroon, when you have a number like this, I'm sure 100% that when you see 650 something, 59 and so on and so forth, is orange number. Generally, MTN starts with something like 670 something, you see, and Camtel generally starts with something like 621 and so on and so forth. Yeah, if I remember well. Now, so you are realizing that this first three digits here is telling us the network. Meaning that from these first three numbers, I know that this network is what? Orange. This next three here, let me just take something like this. I know that, okay, the network is what? MTN. If you take the next, another network is what? Camtel. Meaning what? What differs now? What differs is at the level of these other digits here. Two SIM cards will never have this same digit. It's impossible. You will never have two SIM cards with this same combination. Meaning what varies is just at the level of these numbers here. But generally, the first two or first three numbers are the same for a particular network. And this is the same thing with IP address. Good. Meaning that when people are saying that I'm in the same network with my friend, how to verify if you're in the same network with your friend? Verifying that simply means you need to verify if the network path is what is the same. Good. Having the same network path simply means you're in the same network. But what differs now to identify each device uniquely is what the host path, meaning the number that we have here. Now, and this network path host path now is shared based on the group. You know that an IP address is made up of 4 groups. Meaning what? Maybe the first group can be the network path and the last 3 are the host path. Or the first 2 groups are the network path and the host path is the last 2. Or the first 3 and so on. So we vary like that. Now, after having this information, very nice. The next relevant information I want you to note is at the level of type of IP address. Type of IP address. So yeah, I don't want to waste time. I don't want to waste time. I'm just going to give you the essential things you need to know. Now, there's what we call broadcast. Let me start with network address. Network address. The network address, in fact, is this part here. The network. When we say network address, we just mean by the address of the network, not the address of a device, but the address of what? Of a network. And generally, for you to have network address, you need to determine the network path and the host path from your IP address. Because if you don't know how to determine it, you will never identify the network address. Take note of things like that. Now, generally, how to? Let me just take something. E.g., if I'm having something like 192.168.8.2. This is an IP address. The question now is how to know that, okay, only this first group is the network part and the last 3 are the host part. How to know it? How to know that the first 2 concern the network part and the last 2 concern the host part? So I said that this is a good question. So generally to do so, we are using what we call the subnet mask. If I hear we have different names, either they call it the subnet mask or they call it the network mask, or they just call it what? Mask like this. Take note of that. So if they ask in the exam what is the use of the subnet mask, or what is the use of the network mask, or what is the use of the mask, the use of this is to differentiate the network part from the host part of an IP address. As easy as that. And how is it working? It's very easy. Generally, you will see IP addresses with things like this. Let me clean this. Like this. If one day you see an IP address, then you see a slash here, then after this slash you see a number. Let us say /8. So please never forget it. This number that you are having after the slash is representing what? The mask. And the mask here is telling you that, okay, that the number that you are having here represents the number of bits of the network path. Take note of that, please. So if I'm having /8, 8 here simply means 8 bit is for the network path. If I'm having /16, 16 here means that 16 bit is for the network part. And when you know the number of bits for the network part, the number of bits for the host part becomes easy. Because, like example, if you see /8 here, 8 here means that 8 bits for the network part. And here, when you have this format, you know already that one number here represents what? 8 bit. That one is clear. It's clear for everybody. Now, if you're having /8 here, means that the network part is only this thing here. And what will be the number of bits now for the host part? It's very easy. The total number of bits for the IP address is 32. So you just do 32 minus 8. The answer is what? 24. It simply means that this 24 is what? Is the number of bits for the host part. So this is how we do so. So the mask is just giving you the number of bits for the network part. It's all what the mask is giving you. Now, if you know the number of bits for the network part, automatically you will know the number of bits for the host part, knowing that the size of an IP is 32. Because when you don't have this information, it becomes now difficult. Meaning that even if you have the number of bits for the network part, you will never know how to calculate the number of bits for the host part. So I think I'm clear at this level. So please take note of things like that. Now, there are some questions where things are easier. When I say things are easy, simply mean that the question will clearly say number of bits for the network part is maybe 8. Number of bits for the host part is 24. Like they give directly to you like that, you see. Good. But there are some questions where they don't give it directly, but they use this format slash with a number. So that from here now you are the one to determine that okay, this means this and so on and so forth. Now, so this one information you need to know how to have an IP address and differentiate network part from host part. When you know how to do so now, we come back to the type of IP address. It becomes very easy. Let me do it somewhere here. Type of IP addresses. Now, we say the first one is what? Network address. So what I want you to note is that for you to know the network address, put, or let me just say like that, replace the network, replace the host part with zeros. Full stop. Good. Replace the host part with zeros. So just retain it like this. Putting the host part to zeros is as if you are throwing the host part away. It's as if you are eliminating the host part away because you need what? The network part. So this is just a way of retaining. Let us take an example. E.g. Giving the IP address 192.168.6.7/8. Okay. And they say calculate what? Or they say give the network address of this IP. Now, first thing, you see /8, you know that /8 here means what? That 8 bit is for what? It's for the network part. So the remaining 24 bits for the host part. Now, see the network address is obtained by putting zeros on the host part. This is how you do so. You come here, you say 192, which is 8 bits for the host part, for the network part, sorry. The rest is what? The rest is the host part, so just put .0, .0, .0. Full stop, this is your network address here. Now, when they say putting zeros on the host part, what you are supposed to understand also is 0 here simply means we are assuming, not that we are assuming, we know that each group normally is what? 8 bits, you see. And if you take 8 bits, like if your 8 bit is 8 zeros like this, if you convert these 8 zeros now, 1, 2, 3, 4, 1, 2, 3. If you convert this 8 0 now into decimal, you have what? You have 0. That's why here I'm just putting 0 directly. I hope you get the point. Meaning that in the exam, if they give you an IP address in binary forms, in that case, you not come and do something like this. No, if everything is in binary, make sure that the first binary for the first number you leave it at it is, and the rest of the 8 binary number you just put 8 zeros, 8 zeros. You see. So when I'm putting 0 here, it's because I'm assuming that okay, I fill this 8 0. Meaning that this, because you know that this first number normally in binary is in 8 bits. So I'm replacing all these 8 bits with what? 0 0 0. Convert it back to decimal, you have what? 0. It's the same thing I'm doing with the 6 to have 0. The same thing I'm doing with 7 to have 0. I think it's clear. Any question, just ask in the comment section. So this is how we find network address. Please, network address is just obtained by putting zeros on the host part of an IP. Full stop, nothing else. Now, after knowing this thing, let us go to the second address. The second address here is what we call the broadcast address. What you need to understand concerning broadcast address is, let me just start back. Network address is an address used to identify a network. That one we are clear. Now, a broadcast address is an address used to send a message to all computers connected in the same network. Take note of that, please. If I don't want to write, so just have a notebook and you take note of that. A broadcast address is an address used to send a message to all devices connected in the same network. Very easy. Meaning that if I'm having a network like this, let us say this is my device here. This is a computer. This is a computer here. This is a computer. This is a computer. Good. What happens here is, if this computer wants to send a message, let us say all this is in a single network, meaning it's a local area network, and maybe the network address of this network here is this. This is the network address. Now, if this is the network address, it simply means that the IP address of each computer here is starting with 192. What differs now is what is the rest of the numbers for the host ID. Meaning that maybe this one is having 192.168.6.7. The other one is having 0.6, maybe 8. This one maybe 0.6, maybe 10, 0.6, maybe, you see. The only thing that varies is this part, but this first number will always stay unique. It's not going to change because this is the network part. Now imagine that this PC, let us call it PC A, want to communicate with PC B. For him to communicate, he just needs to know what the IP address of what of PC B. That one is okay. Now, but imagine that PC A wants to communicate with everybody at the same time. In that case, he needs what we call a broadcast address. So, first, you know the meaning of broadcast. Broadcast simply means sending a message from one source to all the other sources connected in that same network. That's the meaning of broadcasting. So, one source, so all the sources in the same network. There's another term we call unicasting. Unicast. Unicast is different. Unicast here simply means sending a message from one source to the destination source directly. One source to one source. Multicast, broadcast means what? Broadcast means one source to all the other computers in the same network. Now there's another one that we call multicast, so I'm not writing, just take note. Multicast simply means sending a message from one source to a group of computers in the network. Not to everybody like broadcast, but just to a group. That's why we call it multicast. Good. When you know the meaning of broadcast, now this may make sense. You see, broadcast address simply means it's an IP address that if you send a message and that your message is carrying the address broadcast, that message is designated to everybody. Meaning that when this central device will receive the message, the central device will just send it to everybody because you have used what? A broadcast address. But if you use a unicast address, meaning that an IP address designated just to one person, when this central device will receive, it's going to forward just to the destination device without sending to the others. And this is exactly how a switch functions. A switch, when we talk about network device, a switch, this hub. A switch generally, because a switch and a hub both are used to interconnect devices in the network. That's why we are clear, because this is star topology. Right? Generally, when people are drawing this star topology, you put what a hub slash switch. Yes, it's correct. Because the central device, either he receives a message forward to everybody connected to him. That situation is when the device is a hub. A hub is doing what we call broadcasting. But a switch now is not doing broadcasting automatically, no. A switch is doing broadcasting when he receives a broadcast address. Else, if a switch is not receiving a broadcast address, he's going to do the unicasting, meaning sending to the destination device. Good. And generally, a switch is not working with IP addresses. A switch works with MAC address. So if I'm just explaining using IP address for you to understand, take note of that. So I don't want to be long. I want to stay in what's essential. Now, the next question you ask yourself is, so how to obtain a broadcast address? So it's very easy. So remember that for network address, we are putting what? We are putting 000 to the host path. Now for the broadcast address, we are putting the put once, let me just write it like that, to the host path. Meaning what? That with the broadcast address, you are filling the host path with 1111111. That's easy. It's all good. And how is it working? Generally, imagine that you have 81, 1, 2, 3, 4, 5, 6, 7, 8 for a single group. 81 converted to decimal is going to give you what? 250, 255. That's why generally you will see we are putting the 255 and not 1. Take note of that. Because 1 in binary 8-bit is built 1, 2, 3, 4, 5, 6, 7, 8. This one here. So if you come here in this group and you replace maybe someone here by just 1 like this, it simply means that this is what you are writing in reality in binary. So when they say replaced by ones, we are talking about the bits in reality, just that it is represented in decimal. So in your head, just know that, okay, if I put 1 in 8 bits, in decimal it's going to give 255. So just replace directly with 250 with 255. As easy as that. So example here. Let me just take this same example. Imagine that I need now the broadcast address of this same IP. The broadcast here is what? Broadcast address. The broadcast address of this IP is clear. You know that the network path is 8-bit, so maintain your network path 192. The host path, you need to fill what? 1111 everywhere. So filling 111, you'll be having what? 255.255.255. Good. Because you know that one group is 8-bit and 81 is 255. That's what we are doing. So this address is for the broadcast address. Clean. When you know network address, broadcast address, for me, you are okay. You are ready for your exam. Now, let me just take another example. Let me clean this. Make sure you pause and you copy. Another example. If I give you an address like this, 192.168, I'm just taking any random address. Take note of that. .16. Maybe 7/16. Good. So let me repeat myself. 16 here means you have 16 bits for the network part, and 16 bits for the network part simply means you are taking the first two numbers, because one number is 8-bit, another is 8-bit, so 8 plus 8 is 16. Good. Automatically the rest here remains for the host part. And normally it's easy to calculate, but if you don't want to calculate it manually with your head, just go somewhere, you write 32, which is the total size, minus the size of the host part 16. The answer is what? 16. Meaning the remaining bit for the host is what? Is 16-bit. Good. And from here now, if they ask network address, what happened? Network address here, you take the network part 192.168, and remember that the host part that you are replacing with what? 0. So this is the network address here. If they ask now for the broadcast address, here, what happened? You are filling by the network, but you are filling by the host part with what? With 111, so 255. So the broadcast address here is 192.168.255.255. Very easy. Nice. So after this is just a small part of computer network. There are so many other things that I've not mentioned here. You see, so there are so many things to note under this chapter. So I think we are going to end this video here. and we meet in the next video to start with June 25. Let us start with the first part at least, so that the next part, now in fact, because there are so many concepts we need to study again before answering 2025. So while answering the year, I will be giving you this concept and so on and so forth. But this one concept I wanted you people to master. So ciao, and see you in the next video.